Unlike equations, inequalities do not provide an exact answer to a problem. Inequalities instead tell us that a solution could be one number, any number within a set of numbers. For example, in an equation we are looking for an exact answer. For inequalities, we're not. An equation may say price equals cost plus profit. If the cost is 80 and the profit is 10, the price is 90. But when we use inequalities, we are not looking for an exact answer. For example, we may say price is greater than cost. If costs are 250, we then write price is greater than 250. Four symbols are used to show inequalities. To show an amount greater than, we place an arrow in the direction of the smaller amount. In this case, the amount shown is not part of the answer. In other words, only greater numbers are true. To show an amount less than, we place an arrow against the direction of the smaller amount. Again, in this case, the amount shown is not part of the answer. To show an amount greater than or equal to, we place an arrow in the direction of the smaller amount and add a line underneath to also show equality. In this case, the amount shown is included in the answer. To show an amount less than or equal to, we place an arrow against the direction of the smaller amount and add a line underneath to also show equality. Again, in this case, the amount shown is included in the answer. Let's see some examples. This reads x is greater than -3. The answer, -2, -1, 0, 1, 2. This reads y is less than 5. The answer, 4, 3, 2, 1. This reads a is greater than or equal to 0. The answer, 0, 1, 2, 3. This reads b is less than or equal to -2. The answer, -2, -3, -4, -5. This reads z is less than -9. The answer, -10, -11, -12, -13. This reads a is greater than or equal to 2.5. The answer, 2.5, 3, 4. This reads b is less than or equal to 7. The answer, 7, 6, 5, 4. Inequalities can be graphed. Inequalities are graphed as arrows that show the direction of the solution. This graph shows x is greater than -3. This graph shows y is less than 5. This graph shows a is greater than or equal to 0. This graph shows b is less than or equal to -2. Notice the difference in plotting greater than and greater than or equal to. When greater than or less than are plotted, the circle marking the limit of the answer is open. When the equal is added, the circle is filled. Like equations, inequalities can be solved by addition, subtraction, multiplication, and division. Inequalities are solved using the same inverse rules we use in solving equations. However, inequalities change directions when we multiply or divide both sides of the inequality by a negative number. For example, in x plus 5 is greater than 7, subtract 5 from both sides. 7 minus 5 is 2. X is greater than 2. The direction of the arrow did not change. Another example. 3x plus 8 is less than 4x minus 7. Subtract 8 and 4x from both sides. Divide by -1 to make x positive. Now, x is greater than 15. Notice that because we had to divide by a negative number, the inequality sign changed directions. Let's multiply and divide inequalities now. For example, 3 times x minus 2 minus 5x is less than 24. Distribute parentheses. Combine like terms. Divide by -2. Change direction of inequality. Another example. Multiply both sides by 5. Divide both sides by 4. Reduce fraction to x is greater than or equal to 10 over 9. One more example. A student's average for 9 tests is 84 points. What is the lowest score he can achieve on a 10th test to raise his average above 85 points? In other words, his average is greater than 85. Make L the lowest score he could get. If the total number of points for 9 tests is 756, then the total number of points for 10 tests is 756 plus L. And the equation 756 plus L divided by 10 is greater than 85 defines the new average. Solving for L. Multiply both sides by 10. Subtract 756 from both sides. L is greater than 94. This means the lowest score must be 95. Any score greater than 94 will raise the average above 85 points.